Hello and welcome to this episode of T-Tech. On today's episode, we're going to look at how we can achieve network redundancy using FreeBSD, Carp, and PFSYNC. I do hope you enjoy it, and let's get into it. Hello and welcome to this episode of T-Tech. On today's episode, we're discussing FreeBSD Firewall Failover. So this is otherwise network failover and or redundancy. Now, network redundancy as a whole, we'll go through that first. So the idea is to make it seem as though the network is always working. So when something fails, our clients should not notice anything and we shouldn't get any calls, ideally. And they shouldn't lose any productivity, okay? Now, this does involve more than just multiple routers and firewalls like we're talking about today. But to have full redundancy, you need multiple switches, you need multiple paths between them, you need multiple UTP cable runs, so Ethernet cable, you need multiple runs of the cabling through the building, you need multiple wireless access points, you even need more than one internet service provider or WAN connection, and with that you would peer with like BGP, the Border Gateway Protocol, and or floating static routes, but that's also, so each router could change where the packets are going. And because you need redundancy on the internet connection as well, because not only can your equipment go down, the provider's equipment can go down that gets you to the internet, or an update or anything. Now, in addition though, you need redundant power supplies and something called uninterruptible power supplies to keep things up when power goes down, and even generators for the entire building. And also hot and cold spare hardware. So spare components and spare hard drives and things like that. The whole idea of telling you all this is just to get the point across that this is not a one and done thing. Doing this one step with FreeBSD will not give you full redundancy in your network. It just won't. It's all the pieces that have to be put together to make it work. So, how do we do this with FreeBSD? Well, there's something called Carp, and that's Common Address Redundancy Protocol. Now, Carp is an FHRP. That stands for First Hop Redundancy Protocol. Now, the idea is to make the client's gateway seem to never stop working. All right? Now, this protocol was first developed in OpenBSD 3.3, but later they ported it to FreeBSD 5.3, okay? So OpenBSD and FreeBSD exchanged code, and then FreeBSD changed it a little bit to work on their system. Now, the whole premise of this is it allows two or more hosts to share a virtual IP address, okay? Now, to do this, the participants in Carp have to be in the same virtual host group. And that term is called a VHID, a virtual host identifier. Now, Carp can also have security added into it. You can do that by using a password. Now, when you use that password, it does have to match for the instance of Carp. So you can have many Carp instances. You just got to make sure the group number and password's separate for each one. Now, in addition to this virtual IP keep talking about, each host has a normal IP address for management. So this is what we use to do things like telnet into the device, SSH into the device, and get information over SNMP or use a NetFlow collector. You would use that IP, not the virtual IP, because you want to get information about the real device. But how does the virtual IP decide where it's going to go? How does that work? Well, states determine who is in charge of the virtual IP at any one time. All right? So you can only have one or the other by default. You can do more advanced things with load balancing, but that's beyond what we're going to configure today. Now, the states that you need to remember. Init, so that's the first state you enter when you turn on the Carp protocol. Okay? Master is the only state in Carp that allows the host to control the virtual IP address. Okay? Now, likewise, backup is the state that will not let the host control the virtual IP. So the idea is the router that's actively processing traffic at the moment will be in the master state. Okay? But the one that's sitting there listening for the master to fail is in the backup state. But he cannot answer directly he can't process traffic for the virtual IP. Now, invalid, that's simply the state that Carp goes into when something goes wrong. Okay? And anyway, the master and backup state relationship with the virtual IP, that's determined by the advertised SKU. Now, in this case, lower is better because the advertised SKU controls how often Carp will send update packets, so hello packets and or keep alives. Now, the reason that it needs to be lower is that means they'll send faster, and that's why the Carp speakers that send faster will be the master role, and the ones that are sending slower will be the backup role, because you can have multiple, you can have more than 2 in one group. Now, preemption in Carp, it allows a host with a lower advertised SKU to assume the master role. All right? I apologize. It's actually supposed to be higher. My apologies. So the higher advertised SKU to assume the master role, meaning they are sending less frequently, but because they're the best Carp speaker in the group at that moment, they will become the master. Okay? But but anyway, that's how that happens, and also though how the if the master goes down, the backup takes over, and the master comes back up. That's how the master will preempt the existing one. Alright, so PFSYNC, or Packet Filter Synchronization, is the protocol that allows the firewall states to be synchronized between the two firewalls. Now, again, it was first developed in OpenBSD 3.3 and then ported to FreeBSD 5.3 in the same way we talked with Carp. Now, it does need a dedicated interface and a separate IP network to send these state updates. And the whole idea is, without PFSYNC, current connections through a firewall that fails will stop working. Now, this would be very important for like road warrior connections and things like that, where your employees are connecting into a VPN outside of the organization. If they're coming in over the WAN, but something on the LAN fails and it switches over, and then the traffic coming from the VPN server on the inside has to go out another router, if it didn't have PFSYNC, it would stop working and have to be reestablished. But with this, we're able to have this failover happen seamlessly without any user interruption. Now, that's the protocols we're going to be configuring and why we need them. In the next slide here, we're going to actually have a little demo of what our network will look like. Okay, ideally anyway. And then lastly, we'll go through a demo of configuring it on FreeBSD. So I'll see you in 1 second. Alright, welcome back. This is how our network will look with redundancy. Okay? Now, the main thing I want you to focus on in the redundancy is the PFSYNC interface here. We have that separate IP subnet just for those state table updates. And then this network here, and this is the LAN network. And this is what we're running Carp on. Okay? And when we say running Carp, we mean the interfaces that are in this network, that's what are sending the Carp packets. Okay? Now, .254 is the management IP for R1, and .253 in the subnet is the management IP for R2. Now, the .1 IP is the virtual IP, and that's what Carp's job is. It's letting either R1 manage it if it's in the master state, or letting R2 manage it if it is in the master state. Okay? But they just can't be in the master state at the same time by default. Now, the idea here is we have the virtual IP and the PCs are configured with that virtual IP, not the management IP addresses. The interesting thing is, though, if you do a trace route when we set this up, in your own lab and whatnot, you will see .254 and .253 if you follow this IP addressing scheme. because the virtual IP stops basically at that interface, okay? And then doesn't stop, but basically when it's forwarded, it is the actual IP of the interface, not the Carp IP. The Carp IP just gets that frame to whatever active router at the time, okay? Now, we'll touch on two other parts of the redundancy. The switches here. Now, we have a partial mesh network here. Switch 4 here connects out to switch 1 and switch 3. And then we have port bundle over here. So we have something like LAG-P or PAG-P, if it's Cisco HP, whatever, switches you happen to have. And the reason we have the bundle is if all the traffic, if this is on, floor 1 and this is on floor 2, because it's just a logical layout, the reason would be if all the traffic has to switch over because switch 4, well, not switch 4, but if one of the links on the outside from switch 5 to switch 2 failed, it would have to go to switch 3. But what that would mean is the worst case would be switch 4 and the link between switch 4 and 1 and 5 and 2 would fail at the same time or in the same day. Traffic would all be switched over now to switch 3. So then you have a bigger influx of traffic, and to avoid higher latency for everyone, you'd have to have more bandwidth and load balance. That's the layer 2 redundancy and layer 1 because we have different links for that. The layer 3 redundancy is the Carp and PFSYNC. PFSYNC is really more like layer 4 because we're dealing with port numbers and things like that for the states. Now, the last redundancy in this network is our internet service providers, and there's something very important I have to explain. Now, this is for the first reason. If ISP1 doesn't update, R1 can use a floating stack route or BGP and then redirect his packets here to ISP2. All right? But same likewise with R2, you can do the same thing. Okay? And that's dual WAN or a multi-homed connection. But the thing is, if R1 fails and it goes over to R2, if both ISPs are up, he has the option of ISP 1 or 2. Okay, so it's interchangeable which way the packets can be routed by either router. Okay? But the thing is, if you have R1 has made sessions or states for PC1's web connection, let's say, or he's streaming or doing a VoIP call outbound. If R1 fails, and then R2 has the states, but they're for ISP1, and this is a corner case, mind you, what would happen is R2 won't hear announcements from R1 anymore, so his Carp state will change to the master. So now any packets sent to the virtual IP will really go to R2. Now, we already synchronized the states, right? Yeah. But the thing is, ISP 1 and 2 have been allocated different subnets by, the organizations above them. Well, those don't match up with the states from R1 that was using ISP 1. All right? So what I'm getting at is, if the router that failed over cannot route to ISP 1, those states will actually be invalid, and the connection won't work. So that is a corner case where you'd still have a redundancy problem and have to reconnect through it. But the main idea with what we're dealing with here is just the fact that R1 is going to be able to fail over to R2, and the 192.168.1.1 IP address will always be available, as well as having the connections still up and not having to be reestablished. So I hope that made sense, and in the next one we're going to do a quick demo of this on FreeBSD, so I'll see you in 1 second. Alright, welcome back. So this part is the demo where we're going to configure this stuff. Now I have 4 virtual machines here. We have R1, R2, a client, and a server. To save time, I've configured the IP address 192.168.1.2 on the client and 192.168 2.2 on the server. All right, those are both /24 networks. So we're going to start on R1. On R1, the first thing we want to do is run fconfig. And our interfaces, what we're going to do is have EM1 be the PFSYNC interface. EM2 is going to be the WAN interface, which will run WAN Carp, and EM0 will be the LAN. And likewise, it will run the LAN Carp. The reason we're running Carp on both LAN and WAN is in this lab, these are both Ethernet segments, and in most times, you would have an Ethernet segment going out to your modem. So, I mean, you can do it like that. So, what we're going to do first is the interface configuration. We're going to do that when we vi etc rc.conf. Hold shift and open, tap O rather, to open a line. And we want to run fconfig underscore, if I can find it, em0 equals, and then in quotes, init 192.1.2.254, and this is the management address with a net mask of /24. That's the management. This is the Carp. We do the same thing but add alias 0 to the end. And then we put an IP address in here. But this one is going to be .1.1 on this subnet with a net mask of /24. After that, we need to put all the Carp specific stuff. Remember the group number? We need to put VHID 10 for this. That's what that is. And we want to put password of test. In production, do use a different password on both Carp instances and a stronger one. Okay, now we're going to move right along to the EM2 interface. And we're going to put the same type of idea, but this one is 254, and the net mask is /24. And we're going to do the same thing to create the other Carp instance. But remember, this is the virtual IP, the 2.1/24 net mask, and we want to put the group of 20 on this one. They need to be separate. And the password test. In production, those should be separate, but in the lab, we're going to have them be the same. Now, we want to do our PFSYNC stuff. So we want to say fconfig underscore em1. We want to set an IP on here of 10.0.0.1 with a net mask of a /30, okay? And now we want to put PFSYNC underscore enable equals yes, and PFSYNC underscore sync dev, which specifies which interface to send the packets out of EM1. Okay? Let's set up the firewall next. So PF enable equals yes, and PF rules equals /etc/pf.conf. Okay? Now we also need to set up the routing, so we want to set up gateway underscore enable equals yes. And the last thing we want to set up is loading the Carp on boot as well. So we want to do boot loader.conf with vi and put carp underscore load equals yes. Escape and save the file. And now we also need to put in etc sysctl.conf at the bottom here. That's we put net init carp preempt equals 1. Okay. And that allows it to take over even though it has the worst advertised skew, the higher one. All right. Now, with that at this point, we can do service. Actually, before we do that, we have to do KLD load Carp and KLD load PFSYNC. So, after all that, then we can do service. Netif restart. And in a few seconds, it'll come up. And we'll double check this. Okay, we're the master for that group. And for EM2, so we're all good on that. Okay, that is that one done, and we want to do service routing restart as well, and that enables the routing on boot. Without rebooting, rather. Now, we need to set up our rule set for this, so that's etcpfconf. We're going to make some macros of lan1 equals em0 and wan1 equals em2. Now we're going to set skip on lo0 and set block policy drop. The set skip doesn't filter on loopback, and the policy drop, set block policy drop, doesn't send replies to drop packets. Now for the NAT, there is something very important. We're going to say NAT on $wan1 from the LAN1 network to any destination, and we're going to say a hyphen and a bracket, space, but instead of specifying an interface, we're going to set an IP address here. We want to set 192 and 168.2.1. And that's the virtual IP, and that's because the server wouldn't know the management IPs of R1 and R2, just the VIP. That's why we have to rewrite the source packets going out to the VIP. So Carp will work correctly on both sides. Alright, now we're going to pass in on LAN1 from the LAN1 network to any destination, and keep state on that. And now we want to let that traffic, whoops, if I could type today, go out WAN1. Okay, and at that point it's still coming from the LAN network to any, and keep state. And then we're also going to pass out from south to any, and that allows the firewall to talk. Alright, and you can put these last two rules up at the bottom or the top. That doesn't really matter. For these particular ones, we're going to say pass proto carp and pass proto PFSYNC. Alright, if we didn't have those, it would actually drop the management packets for these protocols. And one thing I always put in my PF configurations, start it with block drop all. That way everything else is just dropped and not responded to. That isn't part of a state. So let's save this. And now we can test it with the pfctl nf command. We're all good. And let's load it with the F. And make sure it's enabled with the -E option. Okay. So before we go on, we actually need, no, we enabled the routing already. I apologize. So let's just double check everything. All right, our LAN interface and its Carp is working. Our PFSync interface's IP is configured. The WAN Carp is working and configured. And our PFSync interface, oh, we actually didn't restart that. actually. So to do that, we first need to make sure that we put it in rcconf. It is in there. So when you do that, you actually want to do service, PFSYNC restart. And to check it again, just do an ifconfig. Okay, and now you'll see the sync dev is there for EM1. And the sync peer, that's the multicast address for PFSYNC packets. Okay, that is all the configuration on R1, and I'll see you in 1 second, and we're going to do almost the same thing on R2, and then we'll do a demo so you can take time and really understand how these protocols are helping us. So I'll see you in a second. Okay, welcome back. So now we're on R2, and we're going to log in and start almost the same config. So the interfaces are the same in this case. So EM1 is the PFSYNC interface, EM2 is the WAN, and EM0 is the LAN. So we're going to do the same thing. We're going to do ifconfig, EM0, and then the IP will be different, but the idea is the same. 253 in this case. Whoa. Oh, messed up. Alright, and that's a /24. And again, that's the management address. And we want to do the same thing, but alias 0. And this is the Carp information. And that is .1.1 in the same network. But now we have to do that group again, so VHID 10. But on this on R2, we want him to always be the backup unless the master fails. So remember, the advertised SKU is what determines that. So the ADV SKU is going to be 100. And we need to have this be the same password. Okay? The only difference on R2 is the IP addresses and the passwords. Okay? And that the IP addresses and the advertised SKU is the difference. Now, we're going to do EM2, and then this is the management address for that. So 253/24 network. And we want to do the same thing with alias 0. But this one is going to be 2.1 with a /24 net mask. And we're going to say the VHID of 20 and the ADV SKU of 100 and the same password. Now we're going to do EM1. Remember what EM1 was. That's the PFSYNC interface. This one actually has to be 10.0.0.2 with a net mask of a /30. And now we want to actually enable the PFSYNC protocol and tell this protocol which interface. That was with this command where we put EM1 in there. And we also need to enable the PF firewall. So PF enable equals yes. And PF rules etc pf.conf. And now we want to enable routing with gateway_enable equals yes. All right. Now we want to do the thing where we enable Carp on boot. So that is in boot loader.conf, and it's carp_load equals yes. And we're also going to enable the Carp Preemption. Okay? And all this means is if the Carp speakers don't see packets better than themselves, they will take over the master role. Okay? So net init Carp preempt equals 1. Okay. Now, so we don't have to reboot, we'll also do KLD load Carp and service PFSYNC start. And while we're at it right now, we'll also do service netif restart. And this is why we had to load Carp. If you do this before you load the Carp module, those commands diffconfig, it won't know how, it won't know what they are, and you'll get an error message and be a little bit confused. So, the last thing is we want to do our packet filter, and that is in etc pfconf. We're going to make some macros, so lan1 equals em0, wan1 equals em2, and then set skip on L0 to bypass loopback filtering, and set block policy drop so it doesn't send replies to drop packets. And for the NAT, so we're going to say NAT on LAN1 from the LAN1 address to any destination. And remember, this is the important part, to make the Carp actually function on the WAN with the right states, so the packets aren't just dropped. We need to do 192.168.2.1. It's very important. Now we're going to say block drop all to start our rule set, and pass proto Carp as well as pass proto PFSYNC. And then we want to pass in some LAN traffic on the LAN from the LAN network. Rather, just make sure that's a colon to any and keep state. And now we want that traffic to go out WAN 1, but it's still coming from the LAN 1 network at that point. And we're going to keep state on that as well. And we're also going to say pass out from self to any, keep state, and this lets the firewall itself be able to communicate. And make sure you don't forget to spell the full word. Okay, and that's everything we need for this side as well. And I want to point something out. The reason I'm numbering them like that, I can make more macros for more interfaces. So if I wanted another WAN, I could do WAN 2, see? So that's why I do that. But let's save that. And let's verify it. Okay. Now, we're going to do service pf start, and you can also just load the module. But we're going to load the rules. Let's double check and make sure those are in there. All right, and they are in there. So everything is how it should be. And to do the NAT check, do -SN, and then you'll see it there. Okay. Now, we need to check our interfaces. So we're going to do EM0. All right, and as expected, this one is the backup, and that's because of the advertised SKU value. And he's still hearing packets from the master that are better than himself. And EM2 is the backup for the WAN Carp. Let's double checking the sync interface and the PFSYNC 0 interface. All right. Now we are all good. The only thing is a service routing restart. And at this point, just restart R1 and R2 if you're following along. And while we're here, I'm just going to show you while I'm filming. I forgot that in etc sysctlconf. Oh, I did put an equal. I thought I put a hyphen. All right, so I thought I made a mistake, but I didn't. All right. So everything is okay, and the only other thing you should check is the Carp config for the preempt. See how it's not set? We can set that without rebooting as well by running that. Alright, so one more thing before we verify everything is we want to look at EM1, and we can see, well, actually there is no states through there, so actually you will see that when we verify it. But I was just trying to show you that if you look at these interfaces, you will see these advertisements, and that's what each host is seeing, and knowing that they should still be in the position they are in. Same thing with VHID 10, because that's the LAN, and EM2. Same thing on that one, but that's VHID 20. Alright, and that is the multicast address for Carp as well, 224.0018. Okay. Now, in the next part, we're just going to do a verification, because we've done all the tricky stuff, configuring it. We're going to reboot these, do the configuration, and you'll find out why these are so important and how they work. So I'll see you there. Okay, now we're in our verification section. So this is going to be the really cool part. Now, what I'm going to show you first, and I think I already showed you previously, this one is the master though for both of the Carp instances. Now, if we do ifconfig, well, let's do this. There's just so much to show you. Got to get it organized where what I'm going to show you. So, let's ping from the client to the virtual IP first of all. Alright, that pinging is still going along. Now, there is about 2 or so ways to make this failover test happen. We can unplug the cable for that segment that's running Carp, or we can change the state of our Carp interface to backup, or we can also just bring the interface down. Alright, that's just important because there's multiple ways to do this. Because moving the state to backup would be for maintenance, like a graceful failover. But what we're going to do is I made a little program here, and we'll just show you. Basically, it does ifconfig on those 2 interfaces every 2 seconds. So we're going to do that here, and we can see you want to look at Carp master. All right, it's master for both. We're going to run the same program over here. This one's the backup. What I'm going to do is in VirtualBox, I'm going to go ahead and disconnect the LAN, which is the same thing as pulling the cable out. And now he's going to go to backup, and the other side is a net. But the pings are still going for that VIP, because this one is now in the master state. As well, on R2, he's master, but if we do -SS with PFCTL, there we can see the ICMP session that has been synchronized. Because now, if we look, what you won't see it at the moment, but if we bring, let's plug that back in, and you'll see the preemption working. Because now we're going to become the master again, okay? And the ping is still happening, but if we look at EM1, see those packets here? Those are from 10.0.0.1 and the replies. Okay? Those are the state updates. So R2 is taking the state from R1 out of this protocol and putting it in its own state table. That's why it's important to have a separate interface, because someone can maliciously inject firewall states that are not actually allowed to happen. And it will just listen to that and insert them. So we have that going on. And the next thing I want to do is we have this one's master, this one's still a backup. But now we're actually going to do a ping to the server. You remember what the server's IP was, right? It was 2.2. Now we started our ping, and I did start a TCP dump up here. The server is getting packets from the client through R1 at this point because he's the master, and he's replying back through R1. All right. Interesting thing is, let me get these windows a little bit. There we go. If I pull the cable on adapter 1, the other one will switch over and become the master. I'm sorry, if we do look at the states though, you'll have ICMP for 2.2 now. Okay. Likewise, if we connect the LAN again, you see that that'll become master again, and now the packets are going through R1. So this is really good, and there's state information needed for ICMP to be in order and things, but it doesn't break the connection when packets for it come out of order. Okay, where this really is important is with the TCP connections, things like SSH or streaming or anything like that, because TCP still has to have a control connection for that stream to tell the server to send you the UDP packets. But anyway, what we're going to do now is SSH to the server's IP address, 2.2. Type our password, and now we are in the server. And I will prove that by doing ifconfig em0. Now we're on 192.168.2.2. Alright, now I cannot ping backward to the server to the client from the server because of our firewall policy, because of block drop all on that interface. Alright, but what I'm going to do is run top, and you'll see here, basically if I hit spacebar, it refreshes my output. And normally, if you have one router and it fails, this will freeze and say, broken pipe. But that is not going to happen with this TCP connection because of PFSYNC. So, and what we can do as well, it doesn't matter if it's the LAN that is either gracefully demoted or the WAN. So if we do the LAN like we did before, it will go down. And if you look, you can see R1 is indeed in the backup state. But our connection is still going to the server, and you can see every time I hit spacebar, the packets being sent from my computer to the server. But they're from 2.1 because of that NAT. That's why. So, if we Control-C out of this and look at that TCP connection, that's the connection from 192.168.1.2 to 192.168.2.2 on port 22. Even though I didn't establish this in R2, I established it in R1. Well, the last thing I want to show you is that it works on the WAN as well, and after that we'll go ahead and wrap this up. And really, I don't even need to kill this connection. It'll just keep going. We'll go over here and connect the LAN interface. And the state is still in both of them. So now it's the packets have transparently started going through R1, and R1 had the state, so he didn't drop them, because otherwise they would drop them. So we're going to go ahead and do the equivalent of unplugging our WAN connection. Okay. We'll switch over, and we're still going and getting packets at the server, as you can see, but now this one is master. All right. Okay, the only other, thing, we'll just touch on a corner case. If the PFSYNC link goes down, the states will have to be reestablished, either on the WAN or the LAN side, okay? But what doesn't fail is that you'll still have a layer 3 path through either R1 or R2, all right, to your destination. So worst case, even if your PFSYNC fails, as long as your switch is still functioning, you will be able to get frames to one of those routers that was running Carp. So that's how this works. And even if PFSYNC, even if the link fails for the updates, Carp will switch over that first hop for the first hop redundancy and send your packets through R2. You'll just have to reconnect, but it will still work. So with all that, I hope this was helpful, and I hope you enjoyed it. And as always, I'm Tyler with TTech. Hope you enjoyed it. Have a very nice day.